Hello to all attendees and organizers of the 32nd International Materials Research Congress 2024. My name is Kattia Robles and I will present the poster entitled Biochars Produced from Biomass Tomato Waste. Research resulting from a collaboration between CINVESTAV Querétaro, ENES Juriquilla, and UTEC Centro. The study examined the impact of residence time of hydrocarbon production from biomass waste using hydrothermal carbonization. The research found that increasing residence time led to a higher specific surface area and variation in biochar content. The biochar produced from tomato waste could be utilized as water reservoir and water treatment system absorbent or fertilizer for arid soils due to its bioavailable nitrogen content. The tomato processing industry generates a substantial amount of tomato stem and leaf waste containing pectins, hemicellulose, and cellulose, which can be harnessed by the non-food sector. The remaining waste can be repurposed into biochar and hydrochar to satisfy the demand for new raw materials and products in accordance with the circular economy framework. Extensive research has confirmed that tomato waste and the resulting biochar exhibit a higher carbon fraction but lower nitrogen content compared to the other lignocellulosic materials. Therefore, the production of biochar and hydrochar with the capability to absorb low molecular weight organic matter is a compelling solution for treating industrial wastewater, expecting to maximize water treatment efficiency and establish a zero waste system within the tomato production industry. Figure 1 shows in the experimental section the conditions of the different tests are initially shown. The names of the materials to be studied were given in relation to their residence time and molar concentration of acid. All were pyrolyzed at 200 Celsius degrees. To characterize them physically, SEM tests and physical absorption of nitrogen were performed, chemically by FTIR and EDS techniques. Figure 2 shows sulfuric acid solutions of 0.1, 0.25, and 0.5 molar were prepared after hydrothermal synthesis at 200 Celsius degrees for 4 and 24 hours using a mixture of previously crushed tomato stems. Obtaining biochar by hydrothermal synthesis of tomato stems, the ashes were later separated using a 50 mesh. Figure 3 shows a AZM image from tomato stem biomass, previously crushed and dried, where a pyramidal morphology is distinguished. In Table 1, we observe a chemical analysis by EDS of untreated tomato stem biomass. We have the presence of carbon, oxygen, aluminum, silicon, potassium, and calcium. Oxygen and carbon being the most present elements. Figure 4 shows SEM images of biochars produced by hydrothermal synthesis, a constant in the spherical morphology. Figure 5 shows the FTIR spectra obtained, presentive and repetitiveness in its present functional groups. Figure 6 is a spot analysis of chemical composition using EDS from the already processed materials. In Table 2, we observe the results of nitrogen physisorption, where the largest area was obtained in HC4, 0.1 with the lowest residence time and molar concentration of acid. Figure 7 shows the graphs of nitrogen physisorption. The biochars were carefully prepared and analyzed for water treatment as absorbents. This study shows that they are suitable due to their large surface area and various functional groups. A longer residence times leads to higher carbon content, but biochar HC24 0.5 had unexpectedly lower carbon despite a longer residence time and higher sulfuric acid concentration. HC4O.1 with a shorter residence time and lower sulfuric acid concentration had a significantly greater surface area, making it a more cost-effective absorbent. These differences are attributed to the distinct components in each biochar, highlighting the need for a detailed composition characterization. Sources of support. We would like to thank the National Laboratory LITRA from CINVESTAV for supporting extensively in the characterization of the materials. This work was partially supported by UNAM PAPIT. Thank CONACYT Biomass Scholarship.